This is the first video in electrolysis on electrolysis. Now, electrolysis is quite a difficult topic. It's probably the hardest topic in GCSE to understand. Okay, so let's think what it is. It means splitting up a compound, with electricity. Lysis, that means splitting. Okay, so if we think of sodium chloride, okay, now sodium will react with, so here's sodium, and it will react with chlorine gas. So sodium metal, heated up, it will react with chlorine gas, very exothermic, and you will get solid sodium chloride produced. And that reaction, we can see why it's very favorable, because we've got the electronic structure of sodium there, which is 281. So that's very eager to lose an electron, get noble gas electronic configuration. Chlorine, very eager to gain one to get a noble gas electronic configuration. So here we have the ionic solid, we have sodium, noble gas 2,8 configuration, and chloride ions, noble gas also. So that is not going to want to just fall apart back into sodium chloride. That's not going to happen. So in order to do that, to make this reaction go backwards, right, when it goes forwards it's exothermic, so when you make it go backwards you have to put energy in, and that comes from in the form electrical energy transfer. Okay, so just to remind ourselves, sodium chloride is an ionic lattice here. So here's an ionic lattice, so you get a regular arrangement of sodium, positive sodium ions and negative chloride ions. Got a very high melting point. Those ions can't move. Right, now if you try, so we've got here, if you try and pass an electric current through solid sodium chloride, no current flows. So here we've got a cell. There's a negative end of the cell, positive end of the cell, providing a voltage. Here we've got two graphite electrodes. Graphite, of course, is a conductor of electricity, very high melting point, which is important, as we'll see. And we put a light bulb in that circuit here. I haven't used the proper symbol for a light bulb, I've drawn one. And at that point, if you've got solid sodium chloride, no current will flow and the light bulb will not light up. Now, the reason why no current will flow is because when it's solid, the ions are in fixed positions. Okay, so nothing happens. Right. If we melt the sodium chloride, though, if it's molten, then current flows. And that's because the ions can move. Now, in this part of the circuit, it's not going to be delocalized electrons, which is carrying the current. Of course, current is just flow of charged particles. It's going to be the flow of sodium ions and of chloride ions. So let's see what happens here. The sodium ions, which I'll draw like that, they are going to be attracted to the negative electrode. And the chloride ions, by the way, don't worry about calling the anode and cathode, because they always call them negative and positive. The chloride ions, they're going to move to the positive electrode. Let's remember, with what is an electric current, then an electric current is in the wires is a flow of electrons. So I'm going to show the electrons are going to be flowing in that direction, like that, out of the negative end of the battery, and the electrons are going to be flowing up through that wire back into the positive end of the battery. And because we've made the solution, because we melted the sodium chloride, we've now got a current flowing. So I'll draw that light bulb, lights up. So we've got current flowing in that circuit. Now let's see what happens at each electrode. Well, the negative electrode is pumping out electrons. And when those sodium ions get to the graphite electrode, they don't want it, because the sodium ion, don't forget, is electronic structure 2,8. It's got a positive charge. They don't want electrons because they've got noble gas electronic configuration, but the voltage forces them to take on an electron. So if an electron goes onto a sodium atom, what will it do? It will turn it into a sodium ion. So let's write that down. What happens at the negative electrode? we write it as an equation like this. We write down Na plus, and if you give it an electron, which is coming, you'll turn it into a neutral sodium atom. Okay, so all the sodium ions, as they get there, they pick up electrons, they turn back into sodium metal. This is an atom, it's not an ion anymore. And so what you will see is you will see little globules of sodium, sorry, the wrong color. Little globules of sodium will start forming here. So that's Na metal. So you form, okay, so you're breaking down the sodium chloride. Let's see what happens at the positive electrode. Now the positive electrode, you can think of, this is almost like a hoover, and it's hoovering up electrons. It's an electron hoover. And it's taking electrons. So these chloride ions here, they're all going to be attracted towards that because it's positively charged, it's got positive voltage. But when they get there, that they're going to have their electron taken off them. So if a chloride ion goes there, it's going to lose an electron and become a chlorine atom. And there's the electron there. And also, let's remember don't forget, chlorine always goes around in pairs. So as soon as you get two chlorine atoms formed, they join together to form Cl2. So to balance the half, this is an equation, I'll do that, and 2 electrons. And these equations are called, they're called half equations. And the half equations always have electrons in them. Always, they've got E minus somewhere. And they follow the normal rules of balancing equations. So you look for the sodium one, you've got one sodium atom here, one sodium ion here, sorry, and one sodium there. Also, you have to follow not only do they balance the number of atoms, it balances for charges. So if you look on the left-hand side, we've got a plus on the sodium atom there, and a minus on the electron, which makes 0. And what's the charge on the atom? 0 charge on that. Likewise, at the positive electrode, we've got 2 minuses there, and the chlorine molecule is neutral, but we've got 2 minuses from the electrons, so they've got the same charges on both sides of the equation. So the overall effect of that is for sodium chloride to be broken down into sodium and into chlorine. And let's just also say, if you remember, oil rig oxidation is loss, and reduction is gain of electrons. We can see what's happening with this negative electron is reduction, because the sodium is gaining electrons. Whereas at this one, it is oxidation, because the chlorine is losing. It's gaining electrons. Okay, so now let's just see what would happen for some other ionic compounds. So for example, let's see if we've got now one that frequently you do at school is lead bromide, and the reason why that's done is because as ionic compounds go, it's got a fairly low melting point. It melts at like 500 degrees C. You can melt it with a Bunsen, so you can do it. Right, lead bromide is actually made up of Pb2 plus ions and Br minus ions. So what's going to happen then? You're going to get at the negative electrode, the lead ions are going to go there. They're going to be forced to accept 2 electrons because they're 2 plus, and they'll form lead atoms. So you're going to form lead metal will form. At the other one, at the positive electrode, you're going to form bromine gas. But it will be gas because it's very hot, of course, rather than liquid. So you get a Br minus ion. The positive electrode is like a hoover. It will have this electron hoovered off it, and it'll turn into a bromine atom. And that electron here will go up the positive electrode into the circuit. Right, we need to balance that equation because bromine always goes around as Br2, So that means we're going to need 2 bromide ions, and then we get two electrons coming off. So let's just do one more. Another example, we could have, say, magnesium oxide, and that would be really hard to melt actually because it's got a very high melting point, but you could melt it. Magnesium oxide is made up of magnesium ions, Mg2+, and oxide ions, O2-. At the negative electrode, the magnesium is going to go there, Mg2+ ion will be attracted. It will be forced to accept 2 electrons, and you'll form magnesium metal. The oxygen will go to the positive electrode. So you're going to get O2- will go to oxygen, and it has the electrons hoovered off it by the positive electrode, of course. So you end up with 2 electrons on that side. What can we need to balance that oxygen. Obviously you get 2 oxygen atoms, they're going to join together to form O2. So we need to have 2 of those, and that means we're going to have multiply that by 2, so it's going to be 4 electrons there. And those electrons, of course, will go round into the circuit, and they'll go all the way around here, and eventually they'll be given out by the negative electrode, and the magnesium will take them. So there we've got splitting of compounds. You notice it's always the metal that goes to the negative electrode and the non-metal that goes to the positive electrode. Okay.